Welcome to another video by LSX Flashing and Tuning. In this video, I'm going to discuss the different fuel injection systems you might find or come across on marine engines. Also, I'll talk about General Motors fuel injection in general terms also. But first of all, I want to point out the different types for the beginners who don't know a lot about fuel injection. I'm going to point out some basics. This first manifold you're looking at is called a multi-port manifold. It's off an LS motor, off of that engine right there to be specific. But this is called an LS intake, and it's called multi-port because it means you've got a fuel injector there, injector there, injector there, and injector there, and you have four more on the other side. This is off a V8 engine, which basically means you've got a separate injector for each cylinder. All right. And this particular system is called sequential fuel injection, meaning each injector is fired in time to be at the right time for each cylinder. So that one fires, then they don't always fire 1, 2, 3, 4. They fire in a different order, but they fire based on the firing order of the engine. So that's called multi-port. You will never find this kind of intake on a marine application because the Coast Guard regulations do not allow plastic intakes. This is made out of plastic. You don't find plastic anything on a boat. It's against Coast Guard regulations for getting UL approved in Coast Guard or boats, marine applications. But so the marine version of this intake will be all metal. It'll still have the injectors, but instead of having a plastic fuel rail, it'll have a metal fuel rail. It'll have metal braided lines. It won't have a line like that. That's vinyl braided there, but it'll have steel braided. It'll have steel tube for gas. It won't have any metal or rubber parts on it. It won't have any plastic or rubber parts. It'll be all metal. But I just wanted to show you this intake so you'd understand what multi-port means. So means you got a separate injector for each cylinder, and they're timed sequentially. They don't have to be timed sequentially, but in sequential fuel injection, they're timed sequentially for each cylinder. Now this intake here came off a 5-liter Volvo Penta, 1998, I believe. And it was on a Vortec V8 motor, and this is called throttle body injection. Throttle body means this is what's called a throttle body, and by the injection part, that's a fuel injector and that's a fuel injector. So it's only got 2 injectors, and these 2 injectors feed all 8 cylinders. So this is not sequential. In other words, and this works in what's called alternate fire. I'll get into that in a minute, but I just wanted to show you the basics of the difference between multi-port and throttle body injection. This particular throttle body has large 2-inch bores. These were typically used in the car applications. These were used on 454 cubic inch engines. Because these are boat engines, they need a lot more air than a car, a lot more of the time. So I imagine that's why they use these large throttle bodies. These were high dollar back 10 years ago. You'd spend $200 or $300 from these. You could get a standard truck throttle body for about $25, $50. But anyway, that's throttle body injection, okay? So that's the 2 main systems. And you'll notice on this marine intake, the intake's made out of aluminum. There's no exposed parts. No exposed parts that have gasoline in them that aren't metal. Let me see here. So anyway, this intake's aluminum. This is aluminum, so it's all metal parts for Coast Guard approval. All right, so now let's get into how this works. So I'll start with this because this is the older system, and what throttle body systems were used on cars and trucks up to 1995. After 1995, they switched over to what's called the spider systems. They were, I'm not sure if they're batch or sequential. I think they're all sequential. No, actually, I've seen some spiders that were batch before 1995, but I believe in 1996 and then later for cars and trucks, all of them were sequential. They were still spider, but they had 6 separate injectors. And spider just means that the injector wasn't mounted down here. It was mounted up in a pod, injector pod, and that pod had these little plastic tubes that went to each cylinder. Instead of having an injector like that, there was a plastic tube that went here, plastic tube went here. I think they were called poppets. Another tube there, another tube there, and then 4 more on the other side. And on a V8, there was 8 injectors in the injector pod, and on a V6, there were 6 injectors in the injector pod. But all the injectors are mounted up in the top of the engine. The plastic intake up here, you will not find a spider system in a ring again because the intake was plastic. But your spider's set up here high, and the plastic tubes, the poppets, went down to the cylinders. was still sequential because each injector fired individually, but the injectors were mounted up in the intake. And again, you won't find spiders in marine applications. So back to this, you've got 2 injectors on a throttle body application, and that was used up to about 1995 in cars and trucks. And obviously they carried it on. This was off a 1998 Marine with a Vortec engine, so they carried it on for the Marine systems. This particular intake is a Vortec intake. You can tell by the vertical bolts here. And so this intake fits on Vortec heads, but in the automotive world, Vortec engines never had throttle body. So if you have a car with a Vortec engine, you want to go back to throttle body, this will be the intake you'd want to use. I don't know why you'd want to do that, but some people like to do it just cause. So anyway, let me go on to the electronics of this. So if you have a distributor, or this system will always have a distributor, and the distributor looks like this. This happens to be a V8. This is a 5.0 V8 distributor. It came off the same engine this intake came off of. And inside here is a 8-pointed pickup. It's called a reluctor, and it generates an alternating current AC sine wave type signal to the ignition module. That's the ignition module right there by my thumb. And as I discussed in another video how this works, I'm going to go a little deeper this time. So your reluctor generates an AC sine wave, and its frequency and amplitude gets higher and higher the faster this thing spins. It's basically like a little AC generator, alternator rather. And so as it sends out this sine wave, it's in synchronization with the way this distributor turns. So since a V8 has 8 firings, there are 8 pickup points in the distributor. If it had to be a V6, it'd only have 6 pickup points in this reluctor, as opposed to 8. So the 8 reluctor tips in this distributor signal this module here. This module, as I explained in another video, generates a 5-volt square wave, which goes to the computer, and that's how these injector fire. So since this is what's called alternate fire, the pulses coming from the distributor are called DRPs, distributor reference pulses. And what they do is they trigger the injectors in a left-right pattern. So the first pulse triggers this one, the next pulse triggers that one. Then it goes back and forth, left, right, every time it receives a pulse, another pulse from that module. So that's how alternate fire throttle body works. Obviously, these injectors are not timed with any particular cylinder. The fuel goes in, so the fuel that comes in this bore gets distributed to this cylinder, that cylinder, and then on the back, well, it's hard to say, but let me put it this way. If you know that the firing order is right here on the manifold, and that firing order is 1, 8, 4, 3, 6, 5, 7, 2. That's the firing order for every Chevrolet small block V8 ever made. So the firing order, and this manifold is designed to deliver fuel. One side of the injector delivers fuel to, you skip every cylinder, you go 1, 4, 6, and 7. So 1 is here, 4 is in the middle, front middle, 6 is front back, or excuse me, front middle, back middle, and then very back. So 1, you have the outermost cylinders 1 and 7, and the 2 innermost cylinders over here 4 and 6, served by 1 injector. And they are in the every other cylinder in the firing order. So the other injector feeds the other 4, and it does it. And the fuel is distributed by the way the intake manifold is designed to do that. So the intake manifold design, half the injector or half the throttle body feeds half the cylinders, but in the order of in every other cylinder firing order, based on how the intake manifold is designed, and that's for a smooth running engine. Now, in all honesty, at idle, it doesn't matter, because at idle, when the throttle plates are closed, the fuel pulls on top of the throttle plates, and it barely scrapes by the throttle blades, and is sort of atomized and gets distributed into whichever cylinder is calling for it. So if this cylinder's valve is open, it'll suck that in, and if the next one sucks the next bit in. So at idle, it doesn't really matter. The only time it really matters is when these throttle blades are open and the spray goes down. So all the spray from this injector will go into whichever cylinder's valve or whichever cylinder's calling for it the most. and then the next cylinder in the firing order will get the other injector, and then it goes back and forth like that. So I just wanted to point out that the injectors spray in an alternate fire pattern, and it's the design of the manifold that distributes the fuel to the right cylinder, and that's how it works. Now, so these type systems, all they need to run is a distributor like this with an ignition module like that, because that module provides the computer with all the information it needs to run. So the computer gets a signal, a reference signal, fires the injectors. It also sends a pulse, like I explained in my other video, it also sends a pulse back on the, there's actually 4 wires, G, B, R, and E. R is your reference signal going out to your computer, and then the computer sends a signal back on the E wire, which is white usually. E stands for electronic spark timing. So it takes the reference signal on the R terminal and then sends back a signal on the E terminal that's delayed. The longer the delay, the less advance you get on the next cylinder. So what happens is when the distributor triggers, it doesn't fire right away. It waits till the distributor's moved, it's rotated a certain amount, and then it will fire based on how long the delay was from the previous reference signal. So if you want a lot of advance, the delay is shorter, so it fires sooner for on the next post. If you want less advance, it delays longer, so the rotor here moves closer to the next post before it fires. So it works off a delay principle. And it works off the delay principle because the computer can't predict the future. How's it going to advance timing before the signal that tells it when to fire? So it has to work off that delay principle. And it works fine because the distributor is what mechanically moves the spark to the next cylinder. The distributor is your distributor is doing your gross mechanical timing, and the computer is just doing the advance and retard based on delays from when it's triggered. So the trigger is not the actual time to fire the spark. The trigger is just basically the signal to the computer, and then the computer determines when it sparks. Now, if you watch my other video on the Volvo, on how this Volvo works, you'll see there's a special timing tool that you can put in. We back up. This distributor can be used in a carbureted application by not connecting this connector here. This module has what's called a limp home mode, as it has a backup timing curve inside. So if you don't connect a connector to this port and just cover it up with a plastic cap like they do in marine applications with a carburetor, this module actually advances the timing based on RPM on. So it has a built-in timing curve. Again, it gets a signal from the distributor, delays the signal, and then fires it on its own from a built-in electronic timing curve. You can't change it, it's not adjustable. You can adjust the distributor by rotating it and where you tighten it down, but that changes the timing curve everywhere. You can add 5 degrees globally, or you can take 5 degrees away, whatever you want to do, but that's risky. You ought to set it based on the factory specifications. I know that these modules are probably different for a Vortec engine because the Vortec heads do not need a whole lot of timing. I think the absolute gross total timing for a Vortec head or wide open throttle is approximately 20 degrees compared to 30 from some of your older small block stuff. So this module for Vortec application is going to be specific to the Vortex, and you better not use an old 1905 or earlier car module in place of marine, because you might advance your timing too much and damage your engine. So that's how the old throttle body systems work. They're batch fired or alternate fired, and I'd say batch or alternate fire, meaning what that means is that the injectors are not timed for any particular cylinder in any particular manner. They just spray, and whichever cylinder sucks it in is the one that gets it. And again, you only need this type distributor with the signal from this module to run it. That's all the computer needs to run the system. Matter of fact, this module will run an engine with a carburetor, and you only have to have a computer hooked up to it. And that's a lot of the Marines engines with carburetors work. So if you see this type of distributor in your marine engine and you have a carburetor, it's running off the timing built into the module. No doubt about it. Now, that's the earlier fuel injection on marine applications. Let's talk about later stuff. So now, if you find a distributor like this in your boat engine, first of all, you know if it's got a distributor period, it's not an LS motor. This is an LS block. I don't know for those that don't know, LS block or LS engines were started in 1999 and up, and they didn't have distributors period. The computer did all the spark timing completely. Because they had a separate coil for each cylinder, so the computer fired each coil in sequence based on how it's programmed. I won't go into that in this video. That's for another time. But anyway, the Vortec engines using marine applications from 1996 and later used a distributor like this. Now, if you notice the difference, there's no module in this distributor. The only thing it has, trying to take it apart with my hand here, is what's called a cam sensor. You can see the cam sensor right there. It's right there above my thumb. So that cam sensor is fed back to the computer, and its only purpose, is to tell the computer where the engine is at. Okay, and by that I mean, let me get a little deeper here. So the same engine will have this trigger wheel. This is what's called a 4-pole trigger wheel. This is on the front of the crankshaft, and there's a crankshaft sensor. I've got a sensor over here. Let me see if we can pull this up without spilling everything. So this is a timing cover. I'm getting some light here for you. So this is a timing cover off of V8. And there's the crankshaft position sensor right there by my pinky finger. And it sticks in there. You see the tip of it right in there. This is the timing cover on the V8 Vortec. And that didn't come off a marine motor, but it's the same for the marine motors. So if you have a distributor like this, and you have this type sensor, this is a cam sensor, and combined with this trigger wheel on the front of the crankshaft, signaling that crankshaft position sensor, that's what the computer uses to fire the injectors. Now, since it has this 4-pole trigger wheel, it fires the injectors sequentially, but it has to have more information than just this. So if you don't know about engines in general, all automotive engines are what's called 4-stroke. And what that means, I had to rotate twice, 720 degrees, for 1 power stroke out of a piston. So a V8 actually only gets 4 power strokes per revolution. In 2 revolutions, it gets 8 power strokes. So that's why they call it 4 strokes. So in a 4-stroke application, this trigger wheel does not provide the computer enough information so that it knows where it's at in a 720 degree cycle. This only has a resolution of 360 degrees, 1 revolution. There's not enough information in that trigger to tell it where it's at in 720 degrees. That's where this comes in. So the distributor, being timed with the camshaft, the distributor to camshaft ratio is 1:1. So the camshaft and distributor rotate at the same rate, and the camshaft and distributor are timed together. However, the camshaft, because is a ratio with the crankshaft of 2:1. So for every 1 revolution of the crankshaft, for every 2 revolutions of the crankshaft, the camshaft turns 1 time. So therefore, it takes 2 engine revolutions of the crankshaft for 1 rotation of the distributor. And there's the secret to this. So if you look at this signal, so if you look under here, you'll see sort of a half moon or almost a half circle device. That black piece of metal fits down inside that sensor, and as it rotates, it blocks the resolution of the sensor. Is only has 2 points or 2 states, on and off, every revolution. So when it's rotating like that, I guess it's off, and as it comes around, when it stops blocking that sensor, it's on. And then it rotates, and then it's back to off, and then back to on. So this signal is what's called it helps to give this sensor an extra 360 degrees of resolution. So now the computer knows, based on this sensor and that sensor, where this is at in a 720 degree cycle. You need both signals to work. Now, once it has the information for 720 degrees, it can now time the injector to correspond or to fire at a given time with a certain cylinder. That's where you get your sequential. You cannot have sequential fuel injection unless you have both of these sensors. So if you have a marine application and you see a distributor like this, you know instantly that you have sequential fuel injection. It will not be throttle body, it will be multi-port. Throttle body doesn't need this extra sensor to run. So you'll have multi-port fuel injection if you have this type distributor. This will be your key as to what type system you have. All right. Now, having said that, and this is just my hunch. I'll have to experiment and find this out if this is true or not. But if this sensor malfunctions, then and it doesn't have any more, the system, I believe, will still run on just this, but it will go back into what's called batch fire mode. In batch fire mode, it will fire all 4 injectors one time every revolution. Or excuse me, it will fire all 8 injectors once per revolution. So, and that's a backup mode. That's how every multi-port system worked from 1995 and earlier. All the multi-port systems in General Motors cars were batch fire, and they would fire all 8 injectors once per revolution. So you need this sensor for this, because it'll set a code if it doesn't have this sensor, but it will run in sort of a fail-safe mode without this sensor working. Now, to discuss a little more, if you notice this distributor, there's flats where this clamp is, there and there. So this distributor doesn't rotate. That clamp holds it. Once that clamp is bolted down, it holds the distributor in one place. This distributor cannot be rotated to set timing. And the hole that the bolt goes down through here, and then the bolt goes into the intake manifold, this is not distributor that was in here, but the hole in the manifold right here, or wherever it is not slotted. So my point is, this distributor does not rotate. When you set it down in there, the position of this cam sensor is locked. It's fixed. It cannot be adjusted. So it's impossible to adjust so you might say the timing or the synchronization of this sensor on a new distributor. Now, having said that, if your gear wears out down here, and that's why the distributor doesn't have a gear, this particular distributor came out of my son's 2002 GMC truck with a 4.3 V6. The gear wore out, and the slop in the gear allowed us to get a code P0340, I think it was, cam synchronization error. And what happened is that the engineers designed the timing of this sensor with the timing of this sensor such that if they don't synchronize to within a certain amount of degrees of rotation, it'll set a code, because they designed in a certain amount of slop, a few degrees plus or minus, for this signal to appear in the synchronized with this signal. If it gets out of sync, it'll set a code. And what happened was this gear wore out so bad that there was enough slop in this shaft that we set that code. And so I pulled the distributor out, which was a bear, by the way. That wasn't fun to work on. Pulled the distributor out, and we just put in a new distributor. We're going to change the gear out, but the new gear they didn't have it in stock. It was going to take 3 or 4 days for it to get here, so we just ended up buying a new distributor and putting it in. One thing that will happen though, if you do buy new gear, when you put this gear on, you can put it in 180 degrees out. So the gear has to be put on in the right manner. Before you take the old gear off, make sure that its location is marked, or its orientation, the teeth orientation is marked with something with, say the pointer of this rotor right here. So that rotor tip right there, and your gear, if it lines up, no, that hole is not lined up with that. But anyway, you need to mark your old gear relative to this point right here before you take it off, because you'll be a half a tooth out if you put it in 180. If you put it in 180 degrees off, you'll be a half a tooth off, and you'll set that code, the P0430 code. So that's the only way this distributor can get out of phase, because like I say, as long as you put it in, when you put this down in there and bolt it down, it is locked in place. It can't be rotated, so that it's automatically synchronized with this trigger wheel when you do that. So that's the marine fuel injection systems. And again, you'll need this signal and you'll need that. Now, the engine will not run, sequential fuel injection will not run period without this, without the crankshaft position sensor. It won't happen. It'll be a no start condition. But it will run without this signal. It just won't run the way it was designed to, but it will run, and it will run fine. By the way, the ignition, since you have a distributor on this system, since you have a distributor, even if this sensor fails, the computer will still send out the spark signal because it's timed mechanically. Since that's rotating, it automatically sends a signal, sends a spark to the right cylinder by mechanical timing. So it doesn't matter really whether this cam is synchronized or not. This just fires, it just sends out a signal, one signal to fire the plugs. It doesn't care when. The distributor is what times it to the right cylinder. So that's your marine fuel injection systems. And these systems were used on the Vortex systems only from 1990, I'm going to say 1996, possibly later in marine, probably 1999 and on up. One final note, this is not marine, but this is a trigger wheel. It's called a 24-tooth trigger wheel for an LS engine. You won't find these in marine applications unless you have an LS engine. So you can see all the funky teeth on this wheel. And this combined with a cam sensor. Now on the LS systems, the cam sensor, like I say, it's not, I'm just going on, this is general fuel injection knowledge, not marine knowledge. This is the hole for the cam sensor on an LS engine. So the cam sensor fits down in that hole. The crank sensor fits down here on the side of the block right in there. That's where your crankshaft sensor goes. And it picks up this trigger wheel here on the back of your crank. Matter of fact, I've got a crank right there. So you can see there's an LS crank sensor, crank trigger wheel on the back of that crankshaft. So, by the way, this crank trigger, I bought it for $22 from Summit. It's going into an AMC 360. That's a future project I'm working on with somebody else. It's going to be a lot of fun. But so anyway, LS motors have a fixed crank sensor and a fixed cam sensor, so there's no adjustment whatsoever. They will never go out of sync. Won't happen. But if you have a distributor and you have gears wearing, well, but take it back. The LS motors might have the cam sensor go out of sync, but it would take a lot of play in your timing curve, or excuse me, your timing chain for that to happen. I'm not sure if you have enough play to cause that sensor or cause that signal, but the distributors do have a possibility of going out of sync. This ties in again. This ties in with my Dodge series. On if you look at my videos on Dodge 360 Magnum, one of my videos talks about the distributor and the cam sensor, and what I've just said ties in a lot. I'm gonna do a video on that, and it ties in a lot of what I've just said. I'm gonna extrapolate my knowledge of GM fuel injection to the Dodge because they're all similar. None of them are going to reinvent the wheel. They copy each other. So the Dodge has a crank position sensor on the flex plate, the back, basically the flywheel of the engine. It's got 8 pulses, and it has a sensor that picks up that. And it's got a distributor that looks almost identical to this, with almost identical sensor right here. I showed it in the video. And I'm going to discuss that in another video specific to Dodge. But anyway, just want to point that out. But the LS motors have fixed crank and cam sensors, so they never get out of sync. And so there's no way to, you just put them in and crank it up and it runs. I can, the reason my channel is called LSX or LSX Flashing and Tuning is because I know how to program and retune LSX or LS PCMs. I haven't put a lot of that information on my channel yet because I'm in the process of building a 6-liter LS motor. That's going to be the crankshaft for it right there. Hopefully before it's November 2020 or late November 2020, and hopefully before Christmas of 2020, I'm going to have my LS 6-liter motor, if not running, at least put together. And I'll do a series on that also. But I'm going to program it myself and put it in a 1979 GMC truck. But back to the marine situation, these are the 2 fuel injection systems I think you're going to come across. If I come across any more, I'll post up. But this system is for this type distributor and that sensor with the crankshaft position sensor mounted on the front of the plastic timing cover will be your later systems. And this system here will be your earlier systems. Specifically, probably mid to late 90s. And then this will be up in from probably 2000 on. So that's General Motors fuel injection on marine applications. Hope this was informative, and if you have any questions, please leave them in the comments. And if you found this helpful, please subscribe to my channel. I hit the 100 subscriber milestone yesterday, and I'm hoping to get a lot more. So if you'll subscribe to my channel, I'll keep them coming. Thanks for watching.